Session 2.6, Graph of Basic Functions. Continuity. A function is continuous over an interval of its domain if its hand-drawing graph over that interval can be sketched without lifting the pencil from the paper. Let's look at the example. Example 1. Describe the intervals of continuity of each function. Think about it. For this graph, if I use my pencil to graph it, I'm gonna keep going on it. And then until here, I'm gonna lift up my pencil. I'm gonna draw the white dot here, and I'm gonna keep going here. So think about it. The function is not continuous when x is equal to 0. Okay? So when we write it down for the continuous function, we're gonna say the function will be continuous starting from negative infinity until 0 because x cannot be equal to 0. Okay, so you could see we use the parenthesis. And starting the 0 again until positive infinity. Okay, B. This one is going to be keep going like that. Okay, so the continuity will be from negative infinity to positive infinity. Example 2. We do have a function x because this is a piecewise function. When x is strictly less than 1, we're going to use the first equation. When x greater than or equal to 1, then we're going to use the second equation, 4 minus x. Okay, let's start graphing using the table. When x is strictly less than 1, we already know x cannot be equal to 1, right? When x equal to 1, you're going to be using the second function. But we still want to know when x equal to 1, what would happen on this equation. So first point, I'm going to plug in x equal to 1 here. And then this is a y equal to 2x plus 4. You know this is a linear equation, so we try to plug in more points. Plug in 0 or negative 1. Now, plug it in here. When x equal to 1, you do have a 2 times 1, which is 2 plus 4, which is going to be equal to 6. Second one, when x equal to 0, we do have a 4 here. Last one, that will be negative 2 plus 4, which is going to be positive 2. Okay, after we're done for this table, so we could graph the first equation. Okay, you're going to see when x equal to 1 and 6 at this coordinate, we're going to use the open dot to represent it because x cannot be equal to 1. Okay, 1, 6, we're going to use the open dot to represent it. And then we have a 0, 4, negative 1, and 2. Okay, so it's going to be keep going the linear equation. And then now we're going to try to graph the second equation, 4 minus x. Okay, again, x is going to be equal to 1 first. And then you're going to be keep going. 4 minus x, this is going to be a linear equation as well. So we just put it 2 and 4. Okay, plug it in. You're going to get 4 minus 1, which is going to be 3, 2, and 0. Okay, right? So the first coordinate, that will be 1 and 3. 1 and 3. So here. This time, we're going to use the closed circle because this is a equal to. Okay, 1 and 3 here. That's a closed circle. And then 2 and 2. And then 4 and 0. Okay, right? So if we write it down, which interval is going to be continuous? For the first one, we're going to put parenthesis, negative infinity to 1. And then close parenthesis. And then this one, that will be bracket 1, comma, positive infinity, and then close parenthesis. Okay, look at this function. I have a y equal to x, okay, fx equal to x. So you know this is a linear equation. First, I want you guys try to write it down. What is your domain and what is your range? So domain, that will be all possible values of x. So negative infinity to positive infinity. The range, that will be all possible values of y. So from negative infinity to positive infinity. Okay, we're gonna say f of x equal to x is, since this curve is gonna be going up, okay, going up, we call this as an increasing function. Okay, fx is increasing on its entire domain. Okay, so it's keep going up here. The domain will be from negative infinity to infinity. And it is continuous on its entire domain. Okay, one more time. If the curve is going to be going up, we call this is going to be increasing. If going down, like here, that will be decreasing. Okay, second one. First, this is a parabola. Okay, it looks like the U shape here. What is the domain and what is the range? Write it down. Domain will be all possible values of x, right? So from negative infinity to positive infinity. And then the range, we're gonna starting from 0, right? This is the minimum point. So my range is gonna be bracket 0 until positive infinity. Now think about it. When I look at the graph, this is the increasing or decreasing? The first part here, we're gonna be going down, right? So we're gonna say this is gonna be decreasing. On which interval? From where to where? So it will be decreasing starting from infinity until 0 here. Okay, it's going to be decreasing until 0. So at this 0, at this point, this is going to be the turning point. So we just use the parenthesis here. Okay, not equal to 0. We're going to cut it here. And then we're going to increasing on the interval starting from 0 to positive infinity. Okay, this one, f of x equal to x cubed. So it's going to be going like that way. First, find out what is your domain and range. And think about it, it's going to be increasing or decreasing. Okay, domain, that would be from negative infinity to positive infinity. Range, same idea. And then the curve is going to be going up, keep going up, right? So it's going to be increasing. Same idea, it's going to be on entire domain from negative infinity to positive infinity. Okay, square root function f of x equal to square root of x. So think about it. What is your domain? Okay, your domain starting from here until what? And then the range also. So the domain starting from 0, then this is equal to 0. So bracket 0 to positive infinity. And then the range also starting from 0. So bracket 0 to positive infinity. And then the curve is going to be increasing or decreasing. It's going up, right? So it's going to be increase on its entire domain, starting from 0 to positive infinity. Okay, this one. Write down the domain and the range. Domain is from negative infinity to positive infinity. And then the range is going to be the same thing. So this one is kind of going up here. So it's going to be increasing on the entire domain. Okay, last one. Try this one. Pretty similar to the parabola, right? So the domain is from negative infinity to positive infinity. Range is going to be starting from 0. This is the minimum point. So bracket 0 to positive infinity. And then the first part here, the graph is going to be going down. So it's going to be decreasing on the interval from negative infinity to 0. And then it's going to be going up. So that's increasing on 0 to positive infinity. That's it.